All right, we are here for Algebra 2, Unit 2, Lesson 4. We're just going to be talking about some word problems. Pretty easy to set up. Now, many students have the issue with this let statement. Let statement is actually a very easy thing to set up, not very invasive or not very hard to do, and it really just helps you set up your problem. Okay, so in this problem, the sum of two numbers is 5 times the difference. If one number exceeds the other by 7, find the numbers. Well, we're going to make one number equal to x, we're going to make the other number equal to y. And that's all the let statement is telling us. It just gives us an idea of what's going on. Okay, and well, it says 5 times, the sum of two numbers is 5 times the difference. So the sum right there of the two numbers is equal to 5 times their difference, 5 times the quantity of the difference. And then one number exceeds, well, one number, which is x, exceeds the other by 7. So y plus 7 would equal x. Those are our two formulas. Now we've got this one solved for x, so that means I'm going to take this value right here and plug it into right there. So I do that, and I plug it in for this x and this x over here. I get this long equation, and just go ahead and start combining like terms, working the way down, and I get y equals 14. Okay, well, that's the other number. Well, how do I find x? I plug y into that formula right there, which is also right here, and I get x equals 21. So again, let statement really helps start you out, guides you in writing your two equations, and then we're just going to go ahead and substitute one for the other and get it to work out. All right, the next one right here. We've got the measure of one of the two complementary angles is 15 degrees less than twice the other. What are the measures of the two angles? Well, we're going to make one angle equal to x.
Mr. Redhouse, please call 1113.
And we're going to make the other angle equal to y. Okay. The first thing we need to know is x plus y is equal to 90. How did I get the 90? Well, complementary angles equal 90. Okay. And now let's go ahead and write the second equation, because you always need two equations. Okay, and the next equation is x equals 2y minus 15. And that we get from 15 degrees less than twice the other. Okay, and again, we substitute. I substitute this x in for right there. Write that equation out. Go ahead and combine like terms, and y equals 35. Well, how do I get the other angle? Plug in 35 in right there. So I wrote this angle out, and I get x equals 55. And again, 35 plus 55 equals 90 to give us our two complementary angles, and it fits all the constraints that we came up with. Okay. We can write these same type of equations with money. Well, in this one, Liz has 98 pennies, 98 dimes and pennies altogether. She has $3.23. How many dimes and how many pennies does she have? Well, I'm going to make my let statement very easy. I'm going to say let P equals pennies, D equals dimes. Okay, and I can say D plus P plus D equals 98 total coins. Okay, and I'm going to go ahead and solve that for P, so that way I have this entire equation in terms of just one variable. The second equation is, well, a penny is worth $0.01. A dime is worth $0.1. Okay, so number of pennies times that, number of dimes times that should equal $3.23. I don't like dealing with decimals, so I multiply everything by 100 and write 1p plus 10d equals 323. Okay, I can take the p, which I've solved for, which is 98 minus d, plug it into there and solve this equation. So I've done that right here. And I go ahead and solve. That says d equals 25. Okay? That means I have 25 dimes. I plug it back into here, which is right here, and get p equals 73. Okay. The next part, getting a little bit more complex as the problems will. It says a person sold tickets. They started with this number right here on the rolls. They ended up with this number. Carnival tickets are $1 for children, $2 for adults, and the person ended up making $83. Well, first of all, we have to figure out how many tickets they sold. And that's where the ticket numbers come in. So I take the starting ticket number minus the ending ticket number. That means 57 total tickets were sold. Okay? So adults plus children equals 57. Oh yeah, by the way, A equals adults, C equals children. That's my let statement. Okay? A plus C equals 57 for 57 total tickets. And again, I solve the A, solve for A, so I get that. And 2A, which is $2 per adult plus $1 per child, equals a total of $83 right there. And again, I'm going to go ahead and take the A value, plug it into there. Okay, so I distribute the 2 in, combine like terms, solve, and C equals 31. It means children equals 31 kids went to the park or the carnival there. And now I go ahead and plug in 31 for C into this equation right there. Solve it out, A equals 26. So again, important to start with the let statement, find the total number of tickets sold, A plus C equals 57, and the money that they generate is $83, $1 for a child, $2 for adults. Go ahead and substitute and solve. The next set of problems are going to be a little bit more complex, so you got to set up a table. Okay, this is a situation where we have a headwind and a tailwind going upstream or downstream. And so we actually do this. We write a headwind equation, a tailwind equation. Okay, and so our chart starts with rate, time, distance, and actual distance right there. So in a headwind, our x is the speed at which we're traveling with. A headwind kind of slows you down. So you're going to take away from x by some amount of the headwind. Okay? And in a tailwind, you have x, but you're going to be being pushed in the back, so you're actually adding to your speed. Okay? Or adding to your rate there. So in the headwind, it's a minus number. In a tailwind, it's a plus number. Okay? And it says we traveled for 7 hours into the headwind and 6 hours, 1 hour less. So 1 hour less than 7 is 6. Okay? So rate times time gives you 7x minus 7y. And again, we multiply here, 6x plus 6y. And the actual distance traveled was this much, 3,360. So I can say this equals this, and this equals this. Okay, so now I've got two equations with two unknowns. And, well, we're going to go ahead and do an elimination problem. Okay, and solve for it, and we get the plane speed is 520. The tailwind, the wind speed is 40. Okay. And we can go ahead and divide by 6 in each of these and solve for y, plug it in, or we can do an elimination. But the important part is I'm going to leave this part up to you as to how you want to solve it, either substitution or elimination, but the answers are this. Okay. And again, the setup is the hardest part. Okay. Again, upstream would be the same as a headwind. Okay. Downstream, when the water's pushing you faster, same as a tailwind. So we go x minus y, x plus y, okay, and set in our time. Now again, time, you wouldn't put 30 over here because we're looking for time in terms of hours. Okay. So 30 minutes would be half an hour. 12 minutes out of an hour is 1/5 the time. Okay. And we multiply these two, we get over here. Actual distance covered was 5 miles, so put 5 in both of these. So 1/2 x minus 1/2 y is equal to 5. That's one equation. 1/5 x plus 1/5 y is equal to 5. Now I've got two equations and two unknowns, and I can either go ahead and do a substitution or an elimination, and I've left this blank purposely so you can go ahead and do either method to work it out. And the answer should be canoe speed is x is equal to 17.5 miles per hour. The current speed is this. So in one direction, the current is taken away from it, and you're going upstream, you're only traveling 10 miles per hour, and going downstream, you add both of them together, and you go at a much faster rate. Okay. And finally, again, downstream, I wrote down first this way. So again, downstream is you're adding the speed of the current. Upstream, you're subtracting the speed of the current. Okay. Going downstream, you travel 2 hours. Okay. and going upstream, and you took twice the time right here. So again, we multiply, we get this. Okay. 12 miles going downstream, 2/8 the distance, 2/3 the distance of 12 gives me 8 over here. So we multiply, we set this equal to this equal to this. Again, two equations and two unknowns. Go ahead and solve for it. In this case, the boat speed was 4 miles per hour, the current speed was 2 miles per hour. And again, I left this open for work inside class to figure out how we're going to do it, either substitution or elimination.